My name is Gosia Konwerska. I work for Wolfram Research as a developer. I'm going to talk about time series processing, which is kind of the same title as the talk as I gave last year at the conference. And so somehow some things are the same, some things are new. And I'm not going to assume that everybody was here last year and knows everything what was covered last year. So I'm going to start from some basic definition. Feel free to ask me questions. That may need a bit of magnification. Okay, so we basically have three data structures, data objects in Mathematica, Wolfram language, that are designed to store temporally ordered data, which is the time series, event series, and temporal data. And they have been designed with certain, specific goal in mind. And so the time series is designed to store single path objects. We assume kind of that the data is continuous. Event series, we assume that what we store is discrete, so this interpolation between the values does not make sense. And temporal data is the one to rule them all and can store multipath data of either of the types. There are no assumptions made on this. So to start examples, so the creation, so we give the time series, give the values, and then if you give automatic, it's going to automatically feed the stamps, the timestamps, and we start automatically at 0. So this is our initial count. It's going from 0. This is how to create a very basic event series, and this is to create the temporal data. All of these objects have their own typesetting. When you click on the plus here, it's going to give you more information, for example, about the dimensionality of the data, and also about the interpolation, whether it's, you can see here that we have linear interpolation, or in this case of the event series, this is non-existent over there. The main difference here that you see between the time series, event series, and temporal data is what we get when we evaluate the object at the given timestamp. So for time series and event series, we actually get the value that happened to be corresponding to the given timestamps. And for the temporal data, we get the data distribution. Because as I said, this object was designed to store multipath, so we were interested in actually the slice distribution from this data. Then if I ask for what is the value between the timestamps, you see that our timestamps were integers, so I ask for the value at half. The time series gives us interpolated value. Event series tells you, that's not gonna, be there. It's just missing value. And then temporal data gives us the data distribution that comes from the interpolation. So this is an example where the temporal data really comes as a storage is when we simulate the random processes. So this is a random function for the Wiener process on the interval from 0 to 1. And what I have, this 10 to the 4, is the number of the sampling paths. So what we can do here, for example, is to ask for the histogram of the slice of the data at half, and also for the CDF at the same timestamp. And this is the longest evaluation on my talk. So, and here we go. So that's why this data distribution is there for these multipath objects. Properties. So properties can be accessed by the property. Very convenient. So you can see that the time series properties and event series properties are almost identical. There is one thing that is different, which is the path function that exists for the time series, but not for the event series because of this interpolation that we don't have in the event series. And by default, in a time series, we interpolate with interpolation order 1, and this can be seen right when you open here. There is a way to change that, and this can be done via the option resampling method. And so the TS1 will be the new time series where I change the interpolation order to 2, or I can set the the missing values, I mean not the missing, but the values in between the stumps to something else like a constant, say 0. And then the path function here for this gives us the order 2 of interpolation. And here, where we set this value to be constant, we just get a plain piecewise function. And then for the temporal data, the properties, they will include the plurals. So basically, I can have if I give the path, I want to have the first path. If I give paths, I'm going to get all of them. So they're just mirroring. Okay, arithmetic on the time series, it's the new feature that it's coming now. I think it's the 10.2 Mathematica. So what we would like to do is to directly add the time series objects. And the first case is the very simple one is when we have identical timestamps. So TS1, TS2, you see different values, but because I give the automatic timestamps, they are all, the time goes from 0 to 3. And then adding them is clear and straight. Okay, I'm just going to add the values on the existing timestamps because they match. The problem is, okay, I have the timestamps that are not matching. So I create the new time series. This is our way to provide explicitly the list of the timestamps. So this double list gives you the timestamps. So I'm adding some halves here. And the result here, it is a time series object. We can do this, but you see that the time is from 0 to 3 halves. And so what happened is that we are looking at the new timestamps. And so when I plot those, see that the sum kind of is the same short as the TS3. So what happens is that we created the new time series, which is on the union of the timestamps, which lie within the intersection of the intervals coming from the two time series, because that's where those are defined. And this new timestamps, the 1/2 and 3/2, they were not existent in our first time series, but we interpolated. So the values there are the interpolated values. So this is the times on the T3. This is the values coming from the TS1, and we basically add those together and get the result. And then depending on the precision on the timestamps, you're gonna get the same precision on the new values for the interpolating between the timestamps. For the event series, the conditions are much stricter. We really don't have the interpolation, so we cannot do the same thing when we don't have the matching timestamps. So matching timestamps, great. We're gonna end up with the new event series in the traditional way. If I create the new event series and try to add those, when the timestamps are not matching, it's just not gonna go. It just returns unevaluated. Yes. Yes, that's a possibility. Yeah, yes, and so but they need to be there. So you cannot create any new stumps in the event series. So that's the constraint. And when we are dealing with the mixing, so adding the time series to event series, the result will be the stronger one, which is the time series. Yes.
How would you be able to merge event series? Is it possible to say, I have for certain times one event series and for other times the other one, and they belong actually as one data set?
Yes, but that would be the different operation. So you would want to kind of pre-process that.
So you have this outside of the
Yeah. Well, you need to kind of make it to the point when it's gonna be clear what you want with the timestamps.
Okay.
Yes, but as I'm gonna move on to the operations on the time series, that might answer your question. Okay. Also, what would be the right operation to do? Yes. Yeah. Oh, sorry.
Would the addition work if you had set the resampling method to be constant 0?
Event series do not have resampling method.
Okay.
Just don't. The other trick that you can do, you can change this object to time series. So time series on event series gives you the time series, and then you enjoy all the beautiful properties of time series. That might be, So event series, it's really, the number of deaths that you're not going to interpolate between the years, right? So this type of objects. Other operations. For example, taking the minimum, it's going to take the minimum on all the values. If we have, modulo 3 operation on a time series gives us the new time series. And also, we can shift the whole series. And here I would like to say that this shifting means that we are adding this 3 to the values. So we kind of shifted the all values was up, and that works in a direct way. Okay. Double life of timestamps. So there's nothing new about this, as I would say, but the timestamps that we kind of looked at the beginning are integer timestamps. And so we kind of think about the timestamps as they are ordering our observations in time. But especially when we start looking at dates, and for those of you who are coming from the previous talk on the date and calendar functionality, we know that these are the absolute moments in time. So this timestamps served in kind of two purposes. They may set up in space in this kind of not well said, but put us in the time space or order. And in that sense, they have this, for me, double life, as we understand. I will show you an example in a moment what I mean. So the time series with dates, okay, there is one thing that we know the observations happen on a given day. For example, we can look at the time increments between them, okay, and there is the function minimum time increment tells you that they happened, this is the smallest difference in timestamps is 1 day. But also this is a financial data. So we know nothing happens on Sundays, for example. So this is not really that I'm going to have this data here sampled every single day. So a regularly sampled queue tells us that actually that's true. This data is not coming on every single day. And you can see that the differences between the timestamps actually vary because they account for the weekends. Right? This is the business data. This is slightly problematic in the way that we understand the data coming to us on business days is coming in on regularly sampled space because these are the business days, and yet as we are looking naturally at the distances of the day, this is not regularly sampled. So there are at least two ways to deal with this and to teach time series that this data, we want to treat this data as regularly sampled. So one is to use the time series resample. I'll have a list of all the functions working on time series in a moment. And the other option is to force the understanding of the regularity with the option. So set temporal regularity to true. And so we can check that they are indeed regularly sampled. And also what is more important, we haven't changed the path at all. So the paths are exactly the same as our original data. All we did is just the understanding of the steps, that we're looking at this data as coming in our regular steps. And why is this important? Is where we want to take it farther to the processes and actually model with the time series processes, because the ones that we have in Mathematica are defined in terms of the discrete unit time increments. So I'm looking at the steps, and I would like them to come in regular steps to actually fit into the algorithms that we are working with. Okay, so when we look at the example here is the random process, AR process, the autoregressive. The simulation returns us by default the path which is indexed by integers. So these are my consecutive observations. If I look at another process, this is the AR process with the x0 as my initial observation, and this is by default understood as observation happening at the -1 time. And I would like to calculate the mean for this. You see, because this is not a weekly stationary process, this mean is going to change with every step. But we assume that this kind of unit times are the same for each step. And we have two functions that are dealing with the modeling for the time series processes, the time series model fit and then estimated process. So I'll just make sure we have the same data here from the financial data. It's not regularly sampled. And if I try to use the time series model fit on this irregularly sampled data, it recognizes that the assumptions are not met. And it's going to do something about this. And in this case, it's going to resample. So it's going to interpolate on these missing days. Because this data, it's irregularly sampled, doesn't know that it has to come on the business days. The problem is that we are actually looking at the model for this new temporal data, this new time series. You can see it has 92 data points. So what we did was actually to increase the data and have it more to find a model. Right? The original data here at 64. And then estimated process, which is going to say, I'm not going to do this leap of faith here and just fail and just return unweighted and says that it's expecting the uniformly spaced data. So if I take the one that we adjusted, then we can find the models using the time series model fit from the original data or using the estimated process. Okay, so to modify the values and times of the existing time series, we have a suite of functions. This is the list of all of them. Most of them start with time series, and then what would you like to do with this? With the exception of the moving map. So I called it the laundry list, and I'm gonna go fairly quickly through those. Part one will deal with easy numeric examples, part two maybe more abstract. So this is the same time series that I just repeat. So we saw the resampling. Okay, so resample just gives you the either upsampling or downsampling, selecting some values from the existing, or you want to create more by interpolation. Time series shift. This is moving the times. So you see that we had original times 246, now we have 357. So the time series shift will allow us to adjust the timestamps. Window is where we can select some values. So the window is from 3 to 6, so I'm gonna have the 2 observations only in the window. Time series insert, that here 1, 2.8, it means I would like to put the value to point end on the timestamp 1. Okay, so this is my new time series. And then I can also do the same with not just a single time value pair, but also with the new time series. So that would be, I think, a question from Peter, how to intertwine 2 event series. Yes, so this you can stack one into another. Yes. Rescale, this is a situation where we would like to really change the timestamps. And so in these situations, I have timestamps 246. What I would like to do is to now change them into dates. So from today, in the plus 3 more days. And so the important, something important to note here is that the first normal on this time series gives us the date objects in the timestamps. And then if I take the second normal, then it's going to go down to the date list. So part 2. These are the more, I would say, maybe more complex operations. So time series map maps over the values. So this is, for example, a difference between taking the maximum of the just time series. Okay, that will give us the max of all the values collectively. Okay, but if I have here time series which has the values which are 2-dimensionals, I would use time series map to actually take the operation on each value independently. So that's where we still need the time series map, even though there are many operations that work directly on the time series. The time series thread is to combine 2 series, so we can just total or any other function that would work on the values from the both time series. And the map thread is working on both the times and the values from the given time series. So here I'm just having the values being raised to the power, which is a timestamp. in this. Then we have a time series aggregate, which is going to apply a given function over the window. So my function here is just for illustration f, and I'm applying over the window of length 2, so I'm taking 2 values for each instance of function, with exception of the last one, because it's odd. And so that can be illustrated, for example, for the aggregation over the month, and taking the mean. So that's going to be our aggregated monthly mean. And you can see here that the placement of the windows happens to be in the middle of each month. You can read through the dates. Okay. And the last on the list was moving map. And moving map, actually right now I would call it moving map 2.0, because it went through the changes for the 10.2, and many things are new. And also, when Sasha mentioned in his talk, there is some incompatibility, but small. And so I'm just going to focus on what it's doing now to illustrate what we can do with this. So moving map, giving the function, and you can give it also just the data, and then give the window length. So this last argument here is the window of window length. And so you can see that actually f is going to take 3 arguments in it, because it's looking at the window of length too. If you want to specify the number of arguments, that would be equivalent to, say, quantity-free events of this. This works for the irregularly spaced data. Okay, and because it's regularly spaced and we're looking at the window of length 2, sometimes we're going to have 1 element, sometimes 2 elements, depending how they are positions in the time series. And by default, the window is placed on the right. And this is just a comparison where we place the window on the left, center on the right, so we can see how this is moving, and also how the number of arguments in the function is changing. And when we decide to give quantity of free events, which means fix the number of elements, then the position really doesn't change the number of arguments that come into the function. So that was, the function was taking the values. What we can also do now is to give different arguments of the function. It doesn't have to be only the values. So repeating our example, this is the values. We can actually also operate on times, so the function on the times from each window. We can use boundary times, and also notice that some of these boundary times are not the existing timestamps in the time series. So it's looking at I'm still talking about the window of length 2, so it has to have the boundaries of the window, and this not necessarily has to coincide with the existing timestamps. And you can see this definitely when we look here at the boundary values, because those will be interpolated with looking at the values that actually are not existing in the time series. We can place the windows in the result and where we want, really. Give a range of the timestamps, and so on. This is for the events, and for the data time series, this is a more interesting example. Oops, sorry. Excuse me, I just saved my time series in case I lost a connection here. But this is the financial data of Starbucks, and looking at the moving map with the mean, and you see that maybe I should show you the path here. Okay, that's not good, right? Because we cannot really say what it is. But what we can now do is the date path, and we can get dates instead of the absolute times. So the windows are placed on different days. Okay? I can decide, and I would like to have them at the end of each week and say placed on Saturdays. So this is just a little calculation to find how many Saturdays I will have within my data. And then this is the call moving map mean, and then I have it on the right on those dates. Okay, so this is the date path for the moving map. And so what happens is that we actually did a very similar job to what the time series aggregate would do, because the windows that I created are on Saturdays at the length 5. So they're not going to be overlapping. So we kind of recreated the job of the time series aggregate with the addition that we placed our windows where you want. And so when we compare this now to the time series aggregate, you see this is the path of the time series aggregate for this data. It's on Mondays. But when you look at this, the values are the same, but they are just placed on the different days. So the moving map, it's becoming very flexible into basically give us the freedom to place the resulting timestamps where we want. And also one more thing for the moving map is that we can specify padding. So that's our example time series. And the padding just makes sense when we talk about the window length, because if you give the number of elements, that's clearly you just want this many elements. So this is what you get, the error message where you try to apply padding with the events. So don't be scared, okay? If we take the specification here for the length of the window and we say none, that means that I'm going to take all the windows, and you can see that the number of elements in my function f, it varies. Automatic padding means that it's only taking the windows that will have exactly the length 3 there. And then here, this is the padding that has two inputs, so the automatic padding for times and then the constant p for the values. So you can see here that where the p appears, we had the padded value, and then it found automatically what would be the right time to put it into the time series. Okay, I'm almost out of time. So I just want to quickly mention that there's also support in the filtering functions for time series. And what is fairly new is the support for the irregularly sampled time series. And so I'm going to start here. That we can have, this is to just convince you that it's not regularly sampled. It has some crazy minimum time increment, and then 0.2 will be our neighborhood where we look at the mean filter, and then in this sense by default will correspond to the quantity of 0.2 seconds. So that also point out that the filters work with the quantities. And we can also use filters on the time series with dates. And so this is the median filter with the quantity of 5 dates. And just to plot this. So thank you. This is my email if anybody has more questions. And of course, I'll be happy to answer questions